Okay, now covalent bonding and drawing Lewis dot structures is actually, I think, a little bit more important, just because ionic ones are pretty easy to figure out, but like the shapes of covalently bonded things and how those molecules interact are all very, very different. So we're going to start with the basics of drawing Lewis dot structures for covalent bonds. Remember, covalent bonds are anytime you've got nonmetals bonded to another nonmetal where they are sharing electrons. So the reason they share electrons is still because of the octet rule. So for example, in a hydrogen-hydrogen bond, right, hydrogen likes to be H2. Each hydrogen has one electron, and hydrogen wants two electrons. Remember, it's an exception to the octet rule. So instead of one donating it to the other, they just share those two. So they are sharing those two electrons, and we represent that as a bond. We actually draw it as a line. Okay, same thing with a Cl-Cl bond. Okay, each chlorine has 7 valence electrons. So instead of one donating it to the other, they share 2. And so we draw that as a bond, 2 shared electrons. Okay, so in drawing these Lewis dot structures, we have kind of some steps. And if you follow these, you should be able to draw the correct Lewis dot structure for a structure. So the steps are, first, to add up your total number of valence electrons from all of your atoms. So you only have a certain number of valence electrons. You can't just add in electrons or take them out because we're not making ions. We have to have them share so we can like move them around to where we need them to follow all of our octet rules. Okay, so that is a rule you cannot break. You cannot have more or less electrons than what those atoms bring to the structure. Okay, so count up your total number of valence electrons from all the atoms. Remember, it's valence only because the valence are the ones doing the bonding. First thing you want to do is make a skeletal structure. So just put a single bond between each of the atoms. Usually we have one central atom with a bunch of atoms bonded to it. I'll tell you otherwise if it should be like them bonded in a line or something, but assume that there's a central atom and the rest are on the outside. So the way that the formulas are written, usually the first element is the central atom. It is also usually the least electronegative element is the central atom. So remember, electronegativity goes up and to the right. So fluorine is our most electronegative element. So fluorine is always going to be on the outside. Things with lower electronegativities are the ones that are going to be in the middle. So both of those play into our structure. So you put something in the middle and the other stuff on the outside. Okay, then what you're going to do is fill all of your external atoms, all the ones bonded to that central atom, and give them electrons until they all have an octet. Okay, right, 8 valence electrons. Now remember that the bond there is sharing 2, so you're going to add really like 6 dots to each of those atoms to make sure they have an octet. Remember, hydrogen only wants 2, so keep that in mind. Hydrogen doesn't need dots. If you have electrons left then, so once you've filled everything up and you still haven't added up to your total number of valence electrons, then you can put extra dots on the central atom. Now, sometimes that will lead up to an octet. Sometimes it might be more than an octet, but that's where you put the extra electrons. Because remember, you have to have the specific number that your atoms brought with them. Okay. The last step is to check your central atom for an octet, okay? If it has less than an octet, then you might need to try to make a double or a triple bond. Double bond is where instead of sharing one set of electrons, a double bond is where they're sharing actually 4 electrons, so they're sharing 2 sets. Or a triple bond would be sharing 6 electrons or 3 sets. Okay, so in this case, in each of these drawings, each of these carbons has an octet because remember, a bond stands for 2 electrons that are being shared. So like this carbon right here has 2, 4, 6, 8 around it. This carbon here has 2, 4, 6, 8 around it, and whatever is bonded out here. They could be sharing 2, 4, and then each of the other carbons has 6, 8, 6, 8 around it. Or they could be sharing 6 electrons, and then they only need 2 more on the outside. So all of these have an octet represented, but we've just got a double and triple bond. So the only time you should try to add double or triple bonds is if your central atom has less than an octet. Now, if it has more than an octet, because you put those extras on the middle, there's really nothing you can do about it. It just has more than an octet, and that's it. It's just if it has less, you should try to make a double or a triple bond. Okay, those are kind of like the steps. Now, there are some rules also, like don't break this rule. Okay, rule number 1, you cannot break this rule. The group 7A, so the halogens, right? Fluorine, chlorine, bromine, and hydrogen. So group 7A and hydrogen, if they are external atoms, meaning not in the center, they will not double or triple bond. Okay, if you think about it, halogens have 7 valence electrons, so they only need to share one valence electron with another atom to get their full octet. So they are not going to double or triple bond. So anytime they're on the outside, now if it's in the central, it's different, but if they're on the outside, they cannot double or triple bond. Hydrogen can only do one bond because remember it only wants 2 valence electrons. So hydrogen will also never double or triple bond because it only wants those 2 electrons. Okay, another rule is that carbon almost always has 4 bonds, like no dots, 4 bonds. It could be 4 single bonds, or it could be 2 double bonds, or a single and a triple, or something like that. But for actual bonds, it likes to be sharing all 4 of its valence electrons. Groups 2A and groups 3A, so column 2 and column 3, can have less than an octet. Okay, so when we look at the periodic table, here, let me pull up the periodic table, talking about these like beryllium and boron, and you might be like, well, isn't beryllium a metal? It's on the left side of the periodic table. Yeah, but it's not like super electronegativity difference. It has a little bit of electronegativity. So sometimes we will draw these in covalent structures because they're kind of covalent when they bond with things like oxygen or chlorine. So things in this column and this column can have less than an octet. So if they have you can't do a double or triple bond, there's nothing you can do. They're not going to have an octet, and that's okay. In groups 5, 6, 7, and xenon may have greater than an octet. So group 5 here, 6, 7, and I say xenon because we can't get any of the other noble gases to bond. Xenon we can't get to bond, and it has more than an octet a lot of times. So the octet rule is really more of a guideline. If you can have an octet, you should try, but you have to follow all the other rules as well. Okay, so follow our steps for drawing your Lewis dot structures. No double or triple bonds on hydrogen and the halogens. And then you might have broken the octet rule, and that's okay. So here are some examples for exceptions to the octet rule. I mentioned boron. It's in column 3. It's group 3. It is a nonmetal. So BF3 looks like this. I put my one in the middle. I put my fluorines on the outside. I filled up all my fluorines with 8 electrons. And then I ran out of electrons. I just didn't have any more. So I didn't have any to put on boron. You might be like, well, now boron only has 2, 4, 6 electrons. Well, I would try to make a double bond in order to get it to have an octet. So instead of putting these dots here, maybe I would have a boron and a fluorine share 2 sets, except I can't do that because fluorine is a group 7. It is a halogen. It cannot double or triple bond. So there's nothing I can do. This is what the structure looks like. And actually, this is a pretty stable structure. On the other side of it, I said things in group 5, 6, and 7 in xenon could potentially have greater than an octet. So when I had my formula, it's PCl5. I put P in the middle. I put my chlorines on the outside. I filled up my chlorines with dots. That's the right number of valence electrons. I'm done. There's nothing I can do. I don't have more to put on phosphorus, but if you look right now, it has 2, 4, 6, 8, 10 electrons around it. But there's nothing I can do. They all have to be bonded together. And actually, this is pretty stable as well. So again, the rule or the octet rule is really more of a guideline. It is not a hard and fast rule. So kind of keep that in mind. So I'm going to do a couple of these with you, and then I'll have you try them and check them. So in just a second. Okay, I am going to start with NBr3 as my first example for you. So the first thing we have to do is find the correct number of valence electrons. Well, N is in column 5A, so it brings 5 to the table. And bromine is a halogen. It has 7, and I have 3 of them. So that is 21 plus 5 equals 26 valence electrons. So that means my structure has to have 26 valence electrons. Okay, so now I'm going to draw a skeletal structure. I'm going to put N in the middle and bromine on the outside. Remember, usually I do list the middle atom first. Also, the middle atom should be the most the least electronegative one, which N is. So I'm going to go like this: bromine, bromine, bromine. Okay, put them all on the outside. Now, the next thing you're supposed to do is fill up all of the outside atoms, right? So 2, 4, 6, and then remember the sharing ones here means that's 2 as well, so it has an octet. So really I need to put 6 dots on each bromine. Okay, all the ones are on the outside. Now if I have any left over, I need to put them on the middle. Well, I said I had 26 valence electrons, and right now I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. So I have 2 left. So we throw them on the middle. Okay, so then the last thing you should do is check for octets. All my outside guys are good. Nitrogen also has 2, 4, and 6, and 8. So everything is happy here. I don't have to make any double or triple bonds. This is the right number of valence electrons. Okay, so we're going to do another one together. I'm going to do CO2 here. So I'm going to put carbon in the middle. Skeletal structure of oxygen on the outside. I do need to check my valence electrons. Carbon is in column 4, S4. Oxygen is in column 6, it has 6, times 2 is 12, so 12 plus 4, I should have 16 total valence electrons. Okay, so now I highly recommend doing these in pencil because sometimes you're going to have to change them. So I'm going to follow my rules. I have my skeletal, and I'm going to fill up my oxygens because they're on the outside. And then if I have any extra, I put them on the carbon. So right now I have 2, 4, 6, 8, 10, 12, 14, 16. All right, I got all my electrons. I don't have any to put on the middle. Now I need to check my octets. Well, my oxygens are fine, but right now carbon only has 2, 4 around it. So this is a case where I don't have an octet. I should try to make double or triple bonds in order to get an octet for carbon. Now, can my things on the outside make double or triple bonds? Well, they're not hydrogen and they're not a halogen, so yes. Now, I can't just throw on a double bond like that because I just added 2 electrons. You can't change the number of electrons. It has to be 16. So whenever you need to put a double bond on, you put the bond, but you erase 2 of the electrons that were over on this one. So now am I good? I still have 16, but carbon now has 2, 4, 6. So I need to do it again. Okay, now sometimes you won't need to do it on both sides. It's okay to be asymmetrical. Not all these molecules are symmetrical, but I do need to do this again. So now everything is an octet. I have the correct number of valence electrons and I haven't broken any of my rules or of my guidelines. So this is what carbon dioxide looks like. Technically, I could have also done a single bond on one side and a triple on the other, but a double and a double is more stable. All right, now I'm going to do IF5. I'm going to zoom in a little bit so you guys can't see the other one's answer. I've got these 2. These are both halogens. I am going to put I in the middle and then all my fluorines on the outside. 2, 3, 4, 5. And no, you do not have to space them out perfectly or anything. That's just what I'm going to do. Then I'm going to fill them all up. 2, 4, 6. 2, 4, 6. So all my fluorines have octets. And I got to check on my valence electrons. Well, both of these have 7. Okay, so I really have 6 atoms. So 7 times 6, that is 42. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40. So I do not currently have 42. I have 2 more. Well, if you have extras, they go on the middle and you might be like, well, where do I put them? Well, you just put them somewhere around the middle, keep them in a pair. Okay, so now I can check my octets. All my fluorines are fine, but my iodine actually has 2, 4, 6, 8, 10, 12, including those 2 electrons. And you know what? Iodine is actually okay with that. But there's nothing I can do. I have to have 42 electrons. I have to put them somewhere. You put them on the middle. Now, don't try to make double or triple bonds if you have an excess of an octet, because then you're just going to make it worse. Okay, so this is the structure. This is actually what IF5 is going to look like, and that's how you should draw it properly. Okay, so the last one I'm going to do with you is ClO3 minus. Now, what does this minus mean for our valence number of electrons? Okay, let's count our valence electrons. Chlorine has 7. Oxygen has 6 times 3 is 18. So I have 7 and 18, and then this negative means it has an extra electron. Okay, that means I added an electron in. So this is really going to be 7 plus 18 plus 1 is, what is that? 26 valence electrons. You are never going to have an odd number of valence electrons. If you have an odd number, you did something incorrectly. So check your numbers. This has 26 valence electrons. Electrons like to be in pairs. So you're not going to have an odd number. So then let's go ahead and draw this guy. So I'm going to put chlorine in the middle, oxygen on the outside, because chlorine is actually less electronegative than oxygen. That's kind of hard to tell by looking at the periodic table. But I'm going to put chlorine in the middle and I have 3 oxygens, oxygen, 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 just kind of space them out. follow my steps. I'm going to fill up all my oxygens. I'm going to check my numbers really quick. Okay, before I add any to the middle. So I should have 26. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I got 2 more, pop them on the middle. Okay, now check my octets. Oxygens are all good. Actually, my chlorine's good too. Awesome. The only other thing you need to add to these structures, if it has a negative, if it has a charge on it of any kind, you should actually put it in brackets and put the charge on the outside. So that's where those brackets come in. Anytime it's an ion, this is actually a polyatomic ion, right? ClO3 minus, it should look just like this. Now, if you want, you can check the other ones. CF4 should look like this, water should look like this, and then SF4 should look like this. So if you need help, let me know.